presentation will study the 10 years market forecast of photovoltaic in California's market. Photovoltaic is a method of capturing sun's energy using photovoltaic cell and semiconducting material that exhibit the photovoltaic effect. These cells don't need direct sunlight to work. They can also generate electricity on cloudy days. Capacity factor based on California's market is 24.6%. Non-price determinants of demands are market size, expectation of satisfaction, income, market demand, weather or seasonal change. In market size, we study the population growth in California. Energy demand will increase strongly, driven mainly by population growth. When population increases, there will be a higher demand for electricity usage. These local policies eligible customers of PV solar panels for initiative incentives and rebates. This includes residential homeowners, commercial, industrial, agriculture enterprises, and local government and non-profit organizations. Effect of income on demand. The level of income is essential for this analysis. As PV has such a high initial cost, those individuals with larger income have sufficient disposable income to purchase PV panels. States with higher average income tend to have more solar development, even without incentives, because more people are able to afford the technology, or because their government have more capacity to support solar technology. This graph shows the projected average annual growth in personal income in the state of California between 2012 to 2024 is 3.36, 3.45, and 3.09% in high, medium, and low demand scenarios. Overall assessment of demand. By 2024, PV demand will consistently increase and open to a lot of other benign energy technology options. PV is consistent with all sustainable energy patterns and has no real long-term limit on its potential. It will therefore play a major role in eco-restructured transition in the world energy system of second half of the 21st century. This chart shows the difference between demand 1 and demand 2. When the amount of incentives and rebates go higher, the amount of PV solar goes higher. We see there is an increase in demand. Non-price determinant of supply. Resource prices, manufacturing input costs, advancements of technology, prices of other goods that producer can produce, sellers' expectation about future prices, number of sellers in the market, taxes and subsidies. Prices of other goods that producer can produce. The cost reduction of Chinese suppliers are expected to be strong going forward. Declines in the prices of Chinese panels was brought about by supply glut as well as lower raw material prices. Sellers' expectation about future prices. As shown in the top figure, the PV solar will become even more popular in the future, which will cover more than 25% total produced electricity in California. Projects on property utilized for designs, manufacturing, production, and assembly of advanced transportation technologies or alternative source, including energy efficiency products, components, or systems, are eligible for sale and use tax exclusion. Supply and demand forecast. Based on our demand and supply study of PV solar, quantity of demand will increase and price will relatively go cheaper. Quantity of supply and supply will almost remain the same, and price will decrease more. Conclusion. According to our analysis, demand and supply meet each other at the equal opposing forces. Equilibrium price. Potential opportunities. Breakthrough cost reduction in PV technology. For example, substitutes for expensive materials such as silver. Exporting product, service, and energy to developing countries. High CO2 abatement potential. Political and regulatory risk, such as risk of change in policy that may affect the profitability of project. For example, change in level of tax credit or RPS targets. Technology risk. Risk of component generating less electricity over time than expected. Market risk. Risk of a cost increase for key input factors such as labor or modules or rate decrease for electricity generated. Environmental and public health threats. The PV cell manufacturing process includes a number of hazardous material which needs to be handled and disposed properly.